Welcome back. This will be the last and final video on the concept of aromaticity. And so we got a whole bunch of compounds here. Okay. Before I actually walk you through the compounds, I got to give you some information that would probably make sense as I explain things. Okay. A positive charge is equivalent to an sp2 hybridization. Okay. sp2 hybridized carbon. So keep that in mind. Okay. And a negative charge is equal to a pi bond. Okay. Does that make sense? All right. I guess those are the only two things. And then a lone pair of electron is also equal to a pi bond. Okay. If you know these three, chances are you're going to not have any problems with this concept. Okay, I'm trying to keep this video within 10 minutes. All right, so we got our three rules: resonance, planar, and Huckel's rule, right? So you, as I said, you don't need to do them in any specific order. You can do them in any order as you wish. So with that said, a positive charge is same as an sp2 hybridized carbon, right? So that means this is technically, what that means is that when you want to move this is technically, double, single, kind of an imaginary double, single. Okay. If what this really is, what I'm thinking is, if you think of it this way, although this is very incorrect to draw it that way, it's basically like, think of it this way, like the bond is here. So double, single, double, single. That's what this plus charge is. Okay. Or in other words, as I said, for a molecule to be planar, it has to have an sp2 hybridized carbon, right? And so the fact that it has sp2 hybridized carbon means this is considered to be technically a pi bond. At least, this is the way I'm visualizing it, even though if you draw it, that's totally incorrect, totally wrong. But for visualization purposes, this is what your mind should be seeing to really make sense of it, right? So let's look at resonance. Yeah, I'm able to move this here. What that does is, the positive charge is now here. The double bond is here now. Okay. Or actually, let me draw. So I have moved the bond here, right? So the positive charge would be here, double bond would be here. Okay. Because you cannot put this here. You see that there is a bond difference between the plus and, or I can do from here, I can move this here. That means my double bond would be here, right? Right? So those are two different. So what this means is I am able to move my double bond into another place, and I'm also able to move this plus charge, which is a pi bond, into another place. So it follows resonance, right? And the fact that this is sp2, this is sp2, and I just told you a carbon with a positive charge is also sp2. So this molecule contains all sp2 carbons, so it is planar, right? So I'm going to put resonance, planar, and what else? Huckel's rule, which is 4n plus 2. You don't really count this. Positive charge means it has no electrons. So for the purpose of just Huckel rule, you only count the actual bond, physical bond. So this is 2, and I would be able to match that. So Huckel's rule tick. So this is aromatic. Let's come over here. Well, a carbon with just a single bond, you don't see the plus. So this is sp3. So you can straight away say it's not planar. You don't need to even go further into not aromatic is what. It's not planar, so it means it's non-aromatic. You don't need to even go into whether it's whether it meets the other rule or not. It already failed one. You must meet all three to make it aromatic. All right, so let's go over here. All right, so I move this here. I move this here. Well, it certainly follows resonance, right? Because the tail and the head are adjacent to each other. It meets resonance. Is it planar? Yeah, sure. It's double, single, double. So it's sp2, 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 and sp2. Planar, check. Huckel's rule. Well, that's where it fails. So we have 2 electrons for this, 2 for this. So we have 4, right? But we will never be able to match Huckel's rule because Huckel's rule goes like 2, 2, 6, 10, etc. So I will never be able to match 4. So Huckel's rule fails. It's non-aromatic. Okay, same business here. A positive charge is equal to a pi bond. So if I move this bond here, then I move this here. That means the positive charge should actually go to where the actually bond started. But this is the way I will probably test you. Okay, I will probably test you this way. So it's important you need to know where you put the positive charge. So this is come here. This is come here. So again, the matter of fact is I'm still able to match my head and my tail. So that passes resonance. Does it pass planarity? Yeah. Yes, positive charge is sp2. The rest is all sp2. Right? So it's passes planarity. Again, it fails. Positive means no electrons, so that means you only have 4 electrons total, so it fails Huckel's rule. So it's not aromatic. Okay, let's go over here. I'm going to do this one over here because of space. So this one, again, you start here, this here. What this means is negative charge can also, negative charge is a pi bond, right? So you can move the negative charge in. So that means you would get the same feeling here. So this moved here, this moved here. So the negative charge would be here. Okay. As I said, wherever you move it from, that's where you would. So if I move this here further, okay, I would continue my resonance. So I would be, this would be here, this would be here, and the bond charge would be here, right? Wherever you start from, the tail, that's where you put the negative or the positive charge. So again, the tail meets the head, so that means it passes resonance. Does it pass planarity? Well, the negative charge is a pi bond, right? So yes, it does follow follow planarity, because you have double, single, double, right? You don't always have to look at hybridization, but this is equal to a double bond. So double, single, double, single, double, etc. So it passes planarity. Does it pass Huckel's rule? Well, as I said, this is 2, this is 2, this is equal to a 2. So it's 6 total. So that means it passes Huckel's rule as well. So it's aromatic. Let's come over here. As I said, a lone pair is a pi bond. So this is a pi bond. So if I move this over here, okay, then I'll be able to move this over here, move this over here, okay? So this lone pair acts as a pi bond. So yes, I'm able to get my head and my tail adjacent to each other. So it passes resonance. Does it pass planarity? Sure, it's a double, single, double, single. This is not even carbon, so it doesn't even count. So it's only this. So it's sp2, double, sp2, sp2, sp2. So all sp2s means it passes planarity. Does it pass Huckel rule? You sure bet. 2, 4, 6 electrons. So that passes, so it's aromatic. Last but not least is this. So this already is got triple bond. So 1, 2, 3. Head and tail are adjacent. So it passes resonance. Well, this is nitrogen, so this is all carbons. All of them are double, single, double, so they're all sp2s. So it passes planarity, and it's got 6 electrons from 2, 2, 4, 6. So it passes Huckel's rule as well. So this is aromatic. And that's it, folks. You may want to watch a couple of these. You may want to rewind or forward and watch a couple that you think are tricky, like the ones with a positive and negative are usually the trickier ones. So you may want to watch some of it back and forth to get some idea. And of course, I'll give you some more practice workout problems in class. But that's all I have to say on the concept of aromaticity. I think more 2 videos is sufficient to get my point across. The first one is more introduction and then walk you through the various rules. The second one is primarily just walking through the various examples and scenarios where you can see the concept of aromaticity coming to life. Well, that's all I have to say. I think I've prepared enough videos for you to watch, and so stay on top of the videos and ask questions as you go along so that you'll be prepared for the exam. All right, stay tuned for more videos.